Well, there's actually one thing that I was forgetting, and I want to talk about it now. It's a very quick thing. We said before that the velocity of p with respect to a was the velocity of p with respect to b plus the velocity of b with respect to a. That cancels the b. That's what we saw before. But if the velocity of b with respect to a is constant, then something interesting happens. You might remember from calculus, and we saw this in class, that the acceleration is the derivative of velocity with respect to time. So if I take this equation and I try to find the acceleration, if I try to find the acceleration, then the acceleration that p measures with respect to the acceleration of p measured from a, well, this is going to be the first derivative of pa with respect to time, which is going to be the derivative of pb with respect to time plus the derivative of ba with respect to time. But again, if ba is constant, then there is no change. This is zero, and what this tells us is that the acceleration of particle p as measured from a is equal to the acceleration of particle b, p as measured from b. So with constant velocity here between the two reference, a and b, position is relative, velocity is relative, but acceleration is constant. So what I mean is the position of p measured from a and b is relative, depends on where a and b is. The velocity is also relative to a and b. A will measure a different velocity than b, but both observers will measure the same acceleration. That's the last point I was forgetting, and I wanted to include in the video.